Hello all, welcome to Crystal Physics. Today we are going to see that mechanical properties of fluid. So this is important in the board of intermediate. So 2 plus 2 marks. We are discussing only the very short answers. First of all, today we are going to see that average pressure. Average pressure. So everyone know I think. So what is the pressure? The normal force acting on a per unit area. It is known as pressure. So let me write the formula. Pressure is equals to force by area. We have to write SI units of pressure. SI units of pressure. So what are the SI units? The force we have to measure by newtons. Area we have to measure by in the terms of meter square. Or so let me the name of scientist Pascal. So force by area we called as what? So average pressure that was given by Pascal. So that's why we have to call it as. Next topic it is viscosity. So what is the viscosity? Suppose we are taking a pipe. Inside the pipe the water is moving on. So when the water is moving on, it has in the layers. It's the form of layers. That layer should be oppose the motion. So that layers inside getting some forces opposes the motion of the water. So that is known as viscosity. So once see the definition. In fluid, to oppose the relative motion is called as viscosity. So SI unit of viscosity is so Poiseuille or Pascal second. Poiseuille or Pascal second. Important topic it is Magnus Effect. Suppose when the ball is spinning in the air, so what will happen? Whenever it is spinning in the air, it should be lifted. So whenever it is lifting, so that is called as dynamic lift. So whenever lifting, the cause of lift, so dynamic lift, the cause of dynamic lift, the ball is going to spin. So the ball is going to spin. That is known as Magnus Effect. So this effect works on by Bernoulli's principle. So this Bernoulli's principle help us to fly aeroplanes. Thank you. So next concept it is bubbles are spherical. So when we see that surface tension of a liquid, it is surface tension of the liquid of that. So it takes as a minimum surface area for given volume. Only the sphere it takes as a minimum surface area. So that's why soap bubbles or water bubbles are going to be made as a sphere shape. Thank you. So next we see that angle of contact. So another important question. So whenever we have to take the water, so water to the surface area of the water, and we have to draw a one line to here. So tangentially, it makes a angle. The water surface and the solid surface, it makes a some angle theta. It is known as angle of contact. So when we see that angle of contact, theta is 0 degrees. So theta it is when it is the 0 degrees. So it takes as a wetting agent or drying agent, like that it will be work. So for pure water the theta it is 0 degrees. So for mercury it is theta should be 140 degrees. So that's why when we touch the mercury, we shouldn't get any type of liquidity to our hands. But when we touch the water, so we have to get a wet. So cause of what? The angle of contact is very less. Whenever the contact is very less, so that is acting like a wetting agents. Liquid flow through the pipe. Next concept it is liquid flow through the pipe. So when you observing in the pipe, so all the water it is moving on by layers, but we couldn't see that, but so it is moving in a layers. So where it is the more speed of the water, in the pipe itself it is moving the water. So but where it is the more fast of the water. So just we seen that axis line, where we draw the middle of that line, axis line, that line, along the line, so water it is more fast. So compared to these layers, so axis line, the water streamline flow has more fast.